Okay, so now we're going to discuss what a similarity ratio is. And really this makes sense because what we've just been learning is that in order for two shapes or two polygons to be similar, their sides have to be proportional. Well, the similarity ratio is the proportion or the ratio that all of the sides end up equaling. Okay, and so the similarity ratio is the ratio of the lengths of the corresponding sides. Okay, so a couple of ways to find the similarity ratio. As long as there are no fractions, then this will be easy. If there's fractions, you got an extra step to do. Okay, so it says for number one, if there are no fractions in the numerator or the denominator, then you just simply reduce to simplest form. So you just reduce the fraction to simplest form. Okay, so let me do an example like that one. All right, so I'm going to come down here to these. Now, they didn't give us the similarity statement, okay, the similarity statement. So I'm going to have to do that to make this a little easier on myself. So I'm going to call this triangle here GFE. I'm going to go from this angle with the little slash through it to the one with just a single curve. So I'll say triangle GFE is similar to, and then if I want to find the angle that corresponds to G, I'm just looking for the one with the curve and the slash. So that's N. And then the one that corresponds to F is the one with the single curve, so that's L. And the one with nothing is corresponding to E, so that's M. That just helps me a little bit as I get ready to set this up. And I've got all of their sides. Now on your homework, they're going to say something like this on homework 8-2. They're going to say, tell if the two shapes are similar. Well, you got to prove some things about them, okay? This one, first of all, is showing you that two angles are congruent. Two angles are congruent. That would mean that the third angle would also be congruent, okay? So all their angles would be congruent. And they're giving you three sets of sides. Well, you got to check them all. You got to make sure that the similarity ratio on all of those turns out to be the same thing, because if one of them is different, then that means the sides are not proportional. So I'm going to check all three of these. So I'm going to do GF. And what corresponds to GF over here is NL. Remember, we're going from the curve with a slash to the single curve. Curve with a slash to the single curve. So that's NL. So if I compared the two of them, that would be 18 to 30. Well, when you reduce that, both of those can simplify by 6. If you do 18 divided by 6, you get 3. If you get 30 divided by 6, you get 5. So that's 3/5. Okay, then I'm going to do the other sides. I'm going to do FE next. So FE corresponds to LM. So FE is 15. LM is 25. If you reduce both of them by 5, that also gives me 3/5. And then finally, the last one is EG. And what corresponds to that is MN. So remember, the order of these letters matters this time. So that's 12 to 20. And both of those reduce by 4, and that would also give me 3/5. So the similarity ratio is 3/5. But you may be asked not necessarily to give the similarity ratio, but you might be asked to prove whether or not they are similar. So in order to determine that, you have to try all the sides and make sure all of them have the same similarity ratio. If they do, then you will say yes, that they are congruent or that they are similar. And then this will be your similarity ratio. So the similarity ratio for these pair of similar triangles is 3/5. All right, in the next video, I'll do an example of what to do when there are fractions.